So dear students, so this is the homework problems already given in the last class. So this is important for the 5 marks. So once again I want to solve this here. Okay. So this question is repeatedly asked in 2016 and 2017 annual examinations. So therefore it is also very important for your examination. So see here, the function is f is nothing from n to r, be a function defined as f of x is equal to 4x square plus 12x plus 15. So we want to show that f is mapping from n to s. So observe here, but in there f is mapping from n to r be a functions, but the inverse of the function is exist if we take f is mapping from n to s. So s is the where, what is s? S is the range of the function here. The range of f is invertible. Find the inverse of f. So we are going to prove that f is mapping from n to s is invertible. So don't confuse. It's clear that f is mapping from n to s is invertible. That means, so to show that invertible, show solution to show that f is invertible. F is invertible. To show that f is invertible, it is sufficient to show that g circle f of x is equal to identity function of n and f circle g of y is equal to identity function of s. So it is clear that so the function f is nothing from n to s is invertible. So we are taking g circle f of x is equal to identity function of n and f circle g of y is equal to identity function of s. Okay. So where s is the range of the function. Okay. So given function. So let's solve given function. F of x is equal to what? F of x is equal to 4x square. 4x square plus 12x plus 15. So first we are going to convert the given equations into another form for our convenience only. So this is for our convenience only. In the last problem also we are going to same. So we convert the given function into another form. So that means, so see here, f of x is equal to, so this can be written as 2x whole square. 2x whole square is nothing but 4x square. Okay. So now, so this is a square. This is nothing but a square plus, so 2ab format. 2ab format. I want to write the 12x into 2ab format. So that therefore 2 is constant, it is here fixed. So a is already defined. So 2x. A is 2x. So remaining b is what? So without loss of generality, 12x, we are getting 12x after the multiplication of this term. So 2 into 2x is already here fixed. So in place of b, we are going to write 3 only. No other possibilities. So then see here, 2 into 3, 12 into x without loss of generality. So add and subtract b square. Since we are going to write a square plus 2ab plus b square. So b square without loss of generality, we are going to add and subtract 3 square. Is it clear? So without loss of generality, we are going to add and subtract 3 square minus 3 square plus 3 is here. So observe here, I take upper bracket for this. Observe here. So this is of the form a square plus 2ab plus b square. So therefore, so this can be written f of x. Therefore, f of x can be written as a plus b whole square. So this is nothing but a plus b whole square. So a is equal to what here? 2x plus b is equal to what? 3 whole square. Okay. So this is minus 9 plus 15. Minus 9 plus 15. Okay. So then So f of x is equal to 2x plus 3 whole square. Okay, so minus 10 plus 15, that is equal to plus 6. Okay, so this is our new function. So now, so we are convert the given function into another form for our convenience only. Okay, so instead of writing 4x square plus 12x plus 15, we are going to write 2x plus 3 whole square plus 6. Okay, now let f of x is equal to y. So let f of x is equal to y. Okay, so this implies so x is equal to f inverse of y. X is equal to f inverse of y. So we find f inverse of y. So inverse of f. So that's why we are going to put f of x is equal to y here and solve the equation. So therefore above equation become y is equal to 2x plus 3 whole square plus 6. So solve for x. So solve this equation for x. So x is equal to f inverse of y. So therefore we are going to solve this. So then y minus 6 takes this plus 6 on that side. Y minus 6 is equal to 2x plus 3 whole square. Okay, so take root on both sides. So root of y minus 6 is equal to 2x plus 3. So root and get cancelled. So it remains with 2x plus 3. So take 3 this side. So root of y minus 6 minus 3 is equal to 2x. So now x, we want to find x is equal to root of y minus 6 minus 3 divided by 2. Okay, so this is x. So suppose it is taken as equation number 1. So this is taken as equation number 1. So therefore from 1, okay, so f inverse of y is equal to root of y minus 6 minus 3 divided by 2. Just we are defining another function f inverse of y. So define another function, therefore define g, another function inverse of f. We are going to define, just assume that g is mapping from, so f is mapping from n to s. So therefore g is mapping from n to s to n. So g is mapping from s to n such that g of y is equal to root of y minus 6 minus 3 divided by 2. Okay, so we are going to define the another function g of y. So now we are going to verify whether the function g of y is inverse of f or not. We are going to define whether it is inverse of f or not. So for that we are going to verify whether g circle f of x is equal to identity function of n and f circle g of y is equal to identity function of s or not. Okay, so the first one is, okay, so now g circle f of x is equal to, so by definition of a composition function, g circle f of x is nothing but what? G circle f of x is nothing but g of f of x. G of f of x. Is it clear? So now, so f of x is nothing but what? So now f of x is nothing but 2x plus 3 whole square plus 6. Okay, so instead of writing this, we are going to write this. Okay, so 2x plus 3 whole square. 2x plus 3 whole square plus 6 Is it clear? So now, so this is g of x. So g of x is already here. G of x is nothing but what? G of x is nothing but, so instead of y we are taking x. If you take x, this is root of x minus 6 minus 3 divided by 2. Okay, so x is the input, then root x minus 6 minus 3 divided by 2. Okay, so if y is the input, root of y minus 6 minus 3 divided by 2. So your input is what? So 2x plus 3 whole square plus 6 is the input. Okay, so therefore g of 2x plus 3 whole square plus 6 is the input here. So instead of writing x, we are going to write a complete equation, this one. Okay, so therefore, so this equation become, so this become, okay, root of, okay, root of input, okay, root of input minus 6, okay, minus 6, minus 3 divided by what? Divided by 2. Okay, g of x is equal to like this. So we are going to put input x just in this case. So that is 2x plus 3 whole square plus 6. Okay. So now we are going to simplify this. So minus 6 plus 6 get cancelled. So we are left with 2x plus 3 whole square. Okay. Minus 3. So here minus 3 divided by 2. So now root and square get cancelled. So we are left with 2x plus 3 minus 3 divided by 2. Okay, so now again plus 3 minus 3 get cancelled. Okay, so 2 get cancelled. So we left with x. So that is so is equal to identity function of what? Identity function of n. So that is g circle f of x is equal to identity function of n. So this is equation 2. We are going to take this equation 2. So first we are going to verify g circle f of x is equal to identity function of n or not. So obviously we get g circle f of x is equal to identity element of x, identity element of n. Okay. So first write this, and next we are going to verify that f circle g of y is equal to identity element of s or not. Okay. Write down. Okay, so it is better to take screenshot and write next. So once again, I want to repeat this. So we have just verified whether g circle f of x is equal to identity function of n or not. Okay, so remaining is the f circle g of y is equal to identity element of s or not. Okay, so just the given equation is 4x plus 12x plus 15. We are going to change another form. We are going to write the given f of x in another form. So without loss of generality, I am writing this equation as 2x plus 3 whole square plus 6. This is for our convenience only. Okay. So next, take f of x equal to y. So f of x is equal to y is equal to x. Keep here x is equal to f inverse of y. So it is taken as equation 1. So above equation becomes, so therefore 2x plus f of x is equal to 2x plus 3 whole square plus 6 equation become f of x is equal to y. So therefore we take y. Okay, y is equal to. So then we are going to solve for x. So solve for x. So then we get x is equal to root y minus 6 minus 3 divided by 2. So we are going to define another function. F is in the f inverse of y. So x is equal to what? X is equal to f inverse of y. So therefore in case of x, I am going to write f inverse of y. So I define another function. G is mapping from s to n. I am going to define it. Just assume that g is mapping from s to n such that g of y is equal to like this. So next we are going to verify whether it is inverse of f or not. Okay. So next. see now, now f circle g of y, f circle g of y. So f circle g of y, by the definition of composition function, f circle g of y is equal to f of g of y. So say f of g of y. So g of y is not equal to g of y is equal to root y minus 6 minus 6. So f of, just put g of y here. G of y is equal to here. So root y minus 6 minus 3 divided by 2. Okay. So now observe. So this is f of x. This is f of x. So f of x is equal to what? So f of x is nothing but f of x is nothing but see f of x is nothing but 4x 2x plus 3 whole square minus 6 plus 6. Okay. So f of x is 2x plus 3 whole square plus 6. Okay. So observe here. So just this is f of x. This is f of x. Okay. So this is x here. This is x here. Okay. So f of input is equal to 2 into input plus 3 whole square plus 6. Is it clear? So whatever the input you are given, so x is input here, therefore in place of x we are going to write x. Okay. Suppose here y is input, so then we are going to put instead of x it is y. Okay. So here is root of y minus y. Input is what? Root of y minus 6 minus 3 divided by 2 is the input. So therefore, just we put this in this place. Okay. So now the equation becomes, so f of x. So this become 2 into input plus 3 whole square plus 6. Okay. So therefore, input is this. So therefore, root y minus 6 minus 3 divided by 2. Is it clear? So is it clear? So now so here, so we are going to simplify this. Okay. So observe here. So this is the whole bracket. This is the whole bracket. Okay. So now we are going to cancel 2 first. Okay. So we are left with root of y minus 6. Okay. Minus 3 plus 3 whole square plus 6. Okay. So next minus 3 plus 3 gets cancelled. So we are left with root of y minus 6 whole square plus 6. Okay. So root and square get cancelled. So therefore we left with y minus 6 plus 6. So 6 plus 6 minus 6 cancelled. So therefore we left with 1. So this is nothing but g circle, f circle g of y. F circle g of y. So f circle g of y is equal to y. So this is nothing but f circle g of y is equal to identity function of identity element of what? Yes, identity element of yes. So it is taken as equation number 3. It is taken as equation number 3. So therefore, for equation by equation, so therefore by equation 2 and 3, f is invertible. So f is invertible. So one more question is there. So find the inverse of f. Find the inverse of. So therefore inverse of f is equal to f inverse of y is nothing but g of y. Is nothing but g of y. So what is g of y? So g of y is nothing but root y minus 6 minus 3 divided by 2. So this is the inverse. Therefore, so f is from equation 2 and 3. From equation 2 and 3, f is invertible. Okay. So what is the inverse of f? So therefore, inverse of f is equal to f inverse of y is equal to g of y. That means we are defining g of y initially. So finally we are verify whether g circle f of x is equal to identity function of n or not, and f circle g of y is equal to identity function of s or not. So on the basis of this, so we are conclude that it is the invertible. So therefore inverse of f is g of y, isn't it? F inverse of y. Okay, is it clear? Right. Okay, dear students. So in the next sessions we are going to learn about binary operations. Okay. So for 5 marks, so 4 problems are important. So you learn first these 4 problems. Okay. So next we move on to binary operation. Okay. Thank you.